This is a key to section 2.6, part 4, and you want to write the domain in interval notation whenever it asks you for the domain. And so in number 1, you're given these two linear functions, and again, you want to add these two functions, and you want to determine the domain of the new function, and then you're subtracting and find the domain, and so on. Okay, so it doesn't say anything about showing any work, and there's no space here, but obviously you do need to show work on your own scratch paper, but it's not to be turned in. But let's go ahead and look at number 1. So in number 1, you're given these two functions, and you want to add those two functions. So remember, by definition, this means f of x plus g of x, right? And so f of x is negative 2x plus 5. G of x is 3x plus 1. And so I don't need any parentheses here because I'm just adding. And then combining like terms, negative 2x and 3x is x, 5 and 1 is 6. Okay? So this right here, so I have this function, and then I get a new function and add them up, and it's this, x plus 6. Okay? Now remember, these are polynomial functions, right? So these are polynomial functions. These are polynomial functions. And so when I add two polynomial functions, I still get polynomial functions, a polynomial function. And so in a previous lesson, we saw that the domain of a polynomial function is all real numbers. In fact, if you look at this, this is linear. This is a line. It's a linear function, and all linear functions, remember I said functions, all linear functions, the domain's all real numbers. For every x value, you're going to get a y value, and so for every real number, I get a y value back. So you just use interval notation, that's it. Okay, so but you have to remember the fact that this is linear, and even if you didn't, when you add two polynomial functions, you get a polynomial function, and the domain of all polynomial functions is all real numbers. Okay, in C, you want to subtract. So by definition, this is g of x minus f of x. And since it's subtracting, remember subtracting the order matters. So I got to put g of x first. I got to put f of x second. I got to put f of x in parentheses because I'm subtracting all the terms of the function f of x. So g of x is 3x plus 1. Subtract in parentheses f of x, which is negative 2x plus 5. And so distributing the negative through here, I get 3x plus 1. The opposite of a negative 2x is a positive 2x. And the opposite of positive 5 is a negative 5. Combining like terms, I get 2x and 3x is 5x. 1 and a negative 5 is a negative 4. All right, so that goes here. So these two functions subtracted from each other gives me this new function. So 5x minus 4. And again, notice that that's a polynomial function. So polynomial function, the domain is going to be all real numbers. Okay? All right, in 1e, you want to multiply. Okay, so 1e. Now notice I need parentheses there with multiplication. So by definition, this means f of x times g of x. Okay, times g of x. And so f of x is a negative 2x plus 5, and g of x is 3x plus 1. And so since those are two binomials, I can use the FOIL method. So a negative 2x times 3x is a negative 6x squared. The outer is a negative 2x. The inner is 15x. And the last is a positive 5. Combining like terms, put in descending order, I get negative 6x squared. A negative 2x and a 15x is 13x, and then plus 5. So that's my new function. All right. Now, notice that this is quadratic, but it's still a polynomial function, right? That's a polynomial function. So negative 6x squared plus 13x plus 5. And the domain of a polynomial function is all real numbers. Okay, now in G, you are dividing those two functions. All right, so 1g. So by definition, that's f of x divided by g of x. And so f of x is negative 2x plus 5. G of x is 3x plus 1. Okay? And remember, this is rational function. So this is going to be a rational function. So that, and reduce if you can, and I can't factor and reduce, so that's going to stay as it is. So negative 2x plus 5 divided by 3x plus 1. What I want you to notice here is that's a rational function. All right, and remember, a rational function, in a rational function, you can't have 0 in the denominator. You can't divide by 0. So in this rational function, there's some restrictions here. So you got to figure out what makes this rational function undefined. Well, a rational function is undefined when the denominator is 0. So to figure out where this is 0, you set that equal to 0 and solve this equation. It doesn't matter what the numerator is as long as the denominator is not 0. So I get 3x equal -1, so x is -1/3. All right, so that's your restriction. So this is your restriction. So x cannot be that. But remember, you still want it in interval notation, so you got to put that in a number line. So -1/3, cross it out. And so notice that my domain would be all real numbers. My domain would be all real numbers except -1/3. So as an interval, that will be -infinity to -1/3, parentheses, union parentheses, -1/3 to infinity. All right, so that means all real numbers except -1/3. So that's how you would write that as interval notation. So -infinity to -1/3, union -1/3 to infinity. Okay? All right, now in part two, so you have this linear function, you have this quadratic function, and so you want to subtract those. So let's look at 2a. So 2a, by definition, you're subtracting f minus g at x. So by definition, that means f of x minus g of x. And so f of x is 3 minus 4x minus, in parentheses, g of x, which is x squared minus 49. Okay? And so distribute. I get 3 minus 4x minus x squared plus 49. And then combining like terms, let's put this in descending order. I get -x squared minus 4x, and 3 and 49 is 52. All right, so I get -x squared. So that's my new function, -x squared minus 4x plus 52. All right. Now they didn't ask the domain here, but if they did it, since that's polynomial, it'll be all real numbers. Now in part B, they want you to find f divided by g. So it'll be 2b here. So f divided by g. So that means f of x divided by g of x. F of x is 3 minus 4x. G of x is x squared minus 49. Now, again, you have this rational function. If you can factor reduce, you can. I can factor this. Obviously, I can factor this because there's a difference of two squares, but it can be reduced. Okay, so I'm just leaving it like as it is. Since I can't reduce, I'm leaving it alone. So that's going to go here. So that's going to be 3 minus 4x divided by x squared minus 49. Okay? But in part C, they want you to find the domain of this. All right, now remember, just like our discussion here, the domain of a rational function, you first of all have to find out where's this rational function undefined. Well, this rational function undefined when x squared minus 49 equals 0. And so I can do this in several ways. This is the difference of two squares, so I can factor. Or if I notice, since there's no linear term, so you don't see an x term, you just see an x squared, then I can just use the square root property if I bring -49 to the other side. And then take the square root of both sides. I get plus or minus. I get x equals plus or minus 7. So those are your restrictions. Okay, so my domain will be all real numbers. So the domain would be the set of x's such that x is a real number and x does not equal plus or minus 7. Okay? But they want you to write this in interval notation. So in interval notation, so remember how to do that. You got to put those two numbers on the number line. So here's -7, here's 7. You got to put them in order. You can't use those. So notice that those two restrictions divide the number line into 3 intervals. So you're going from negative infinity to negative 7, union, negative 7 to 7, union, 7 to infinity. Okay? And so that's the answer to 2C. So 2C, for 2C, you're going to say this right here. So negative infinity to negative 7, union, negative 7 to 7, union, 7 to infinity. Okay? All right, so that was the key to worksheet 2.6, part 4.